All right, so transformations on exponential functions. Because transformations really never do go away. So we graphed yesterday, we graphed y, base 2, exponent x. You guys know that 2 is the base, x is the exponent, the whole thing is referred to as a power. Right? Yes? Just because it might make a difference depending on what the question's asking you. When it talks about the power, it's talking about evaluating the whole thing. Okay, so now today we're going to do the transformations on x. So if there is a negative in front of the x, what happens? It's definitely a reflection. It's on the x. Okay, you guys need to listen to me because my pen is having, that's supposed to say in the y-axis, so just go with that. So if we did that, what would the domain look like? Do you guys remember the graph from yesterday? Right, so it did that. What are some key points? What's this point right there? 0, 1. What is, when x is 1, what's y? Right? So that's from yesterday. So if we reflected it in the y-axis, so now this is going to flip the upper part, like the increasing function is going to switch to a decreasing function because it's going to flip over the y-axis. Does that make sense to everybody? So what's the domain look like? Yeah, so now we've got this graph, right? We've got this exponential function for this one here. So the domain, still the same. Range, still the same, right? But what is the same? Does it include 0? No. Y-intercept? 1. And where does that asymptotic behavior happen? Right, so I'm dealing with a horizontal line, so my asymptote would be y equals 0. Does that make sense to everybody? So it's that asymptotic behavior we're talking about. Okay, so now I got the 3 in front. So no reflections, there's nothing negative here. Oh wait, go. Okay, so the 3 is in front, and what's happening? No, it's not an up, because an up would be an add. We're multiplying by 3. So that's a vertical stretch by a factor of 3. Best I can do. Okay. So we're going back to our original function, which is this one. So what's happening with this one? Is it going to cross the x-axis? No. Is this graph is going to get taller, faster? It'll go up faster. That's a technical math term, but it'll go up. So the domain isn't going to change. It's going to be negative infinity to positive infinity. You're just getting a steeper curve. The range still going to be the same. 0, positive infinity. y-intercept. Now we're at 3, because we would take any y values and multiply them by 1. Something wrong with Layton? No? We're like, no. No, sorry, you come late. And the asymptote? Y equals 0. The asymptote didn't change. All right, so now we've got the negative in front of the 2. This is the reflection in the x-axis. That's supposed to say reflection. I would go very slow. The domain, what's the domain now? Still the same. So negative infinity to positive infinity, but the range has changed. You reflect it in the x-axis. So the original one used to go like this. Now what is that going to look like? Like that, right? Remember, okay, so negative infinity to 0, not inclusive, y-intercept. Now it's at -1, and my asymptote, y is equal to 0, that didn't work, right? So anything that's multiplied, if you just have like a stretch or a reflection, if it's a multiplication, you're going to see that that asymptote doesn't move. That asymptote doesn't change when you're multiplying. Okay, so for the next one, there's a 3 in front of the x. Right, so we have a horizontal we'll call it a stretch. By a factor of how much? Okay, that's as good as I can do. Domain. Still the same. Range. What is it? That one? Negative what? 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 It's still the same, it's 1. Okay. This is Konami, you're screwing me up. I'm listening to you, we're lost. Asymptote? Y equals 0. All right, moving on. Okay, so this is where things start to shift. Okay, so we have x minus 1. Where are we going? So we're going 1 unit right. The domain of this. Okay, yeah. Range. Same thing. Same as the original. Ooh, that y-intercept. It's a half. Right, you're taking all the points and moving them 1 to the right. So at -1, what was our point? It was half. So now we have to shift that graph 1 to the right. So that would mean when my y value is 0 now. We're sorry, when my x value is 0, my y value is going to be a half. Does that make sense to everybody? We're like picking up that graph and moving it over. Or you're going to take your x values, -1, add 1 to it. Where are you? Because we're doing a derivative of values, right? It means we're taking all of our x things and we're adding 1 to them to do a mapping rule. And the asymptote, still the same. I know, no judging. Do my best here. All right, last one. Where's this going? It really isn't. Okay, so waiting for this one. Domain doesn't change. Range does though. Because if my asymptote was originally at y equals 0, and I'm shifting the whole graph down 1, that means my asymptote is going to shift as well. So my range is going to be -1 to infinity. Does it include -1? No, because we never touched that asymptote of 0. Where's my y-intercept now? Right? Because it used to be at +1 and we're subtracting, and it's going to be at 0. Asymptote? What? I give up. Y equals -1. David, you might get your wish. I don't know if I can do all this technology not working again. Yeah. I'm not recording. I am recording. I am. See, it says recording down here. I just can't open it. Yeah. No, we're good. We're good. But what do you mean I'm not recording? Okay. Yeah. You want to tell us what the purpose of that one is? I don't know. I think David's trying to think.
I was really good, Joe. It would ruin my life.
Well, I'm glad I didn't ruin your life. Okay, so the hint I'm giving with this one is graph or put on there your base function. Okay, like so the base is base 3. So we're going to do the table just for this one because we haven't looked at this. We did 2x yesterday. So -2, -1, 0, 1, and 2. So if 3 to the exponent 0 is 1, 3 to the exponent 1 is 3, 3 to the exponent 2 is 9. If you do these ones first, you work backwards. What's 3 to the exponent -1? Of course. And that one would be 1, not going to be 0. Yeah. When I taught grade 9 teaching this, I call them up-down charts. So you do this part, and then when you do negative exponents, you just do the reciprocals. Because if you take 9 and divide it by the base number, which is 3, what do you get? 3. If you divide 3 by 3, what do you get? 1. If you divide 1 by 3, 1/3. You divide 1/3 by 3, you get 1/9. There you go. Yeah. I call it the up-down chart. What? Really? You didn't pay attention on that? Oh, there you go. So please note that I'm putting this function on with a dashed line. How come I'm doing that? Dashed lines don't exist. It didn't ask me to graph this, but it's going to be helpful for me to graph it. So if you're going to do that, you need to make sure that it's represented by a dashed line. I also think you can get away with it if you just label it. If you did a solid line and you labeled it, I'd be hard pressed to take marks off. It doesn't exist. Asymptotes are actual function lines. That's why we always draw them in with dashed lines. You actually lose a half mark on your asymptote. Asymptote drawn in as a solid line. Your asymptote has to be a dashed line. Dashed lines don't exist, but they do show like imaginary. Kind of like when you guys were little and you would draw pictures of your imaginary friends or, you know, do you? Okay, fair enough. Okay, so with this information, I can now do the transformations. So this is telling me that I've got to move 3 to the right and 4 down. So if we were to do a table of values, I don't know if it's worthwhile if we writing on the board after a while. Let's go say X, Y. If we were going to do a table of values, this is telling you to move 3 to the right. So if I'm at -2 and I move 3 to the right, where am I? I'm positive. No. -1, add 3 is going to put me at 2. 0 is going to move to 3. 1 is going to move to 4, and 2 is going to move to 5. Now for the y's, it's saying subtract 4. So this is your knowledge of fractions that's going to come in. So we're going to have 1/9 subtract 4. So I'm going to be at -3 and 8. Oh, I was doing so well there for a second. -3 and 8/9. What about the next one? -3 and 2/3. Now we're in whole numbers, so it's a little bit easier. 1 minus 4 is going to put me at -3. 3 minus 4 is going to put me at a -1. 9 minus 4 is going to put me at a +5. It's really important, guys. There's been no stretch. There's been nothing. So essentially what we're doing is we're moving this graph. We're shifting it this way and down. So this shape should be preserved. So if you graph it and you have a point that like creates a spike in the graph or something like that, you know you've done something mathematically wrong. Okay, so we're going to plot these. So at 1, you know what we should do? What should we do first? Who knows? Crazy Mescallion. I will move my asymptote first. So if my asymptote is at 0 and I go down 4, I'm going to be at -4 now. I like putting the asymptote on there because it reminds me of my boundary. All right, so at 1, I'm at -3 and 8/9, so I'm really, really close to that asymptote. At 2, I'm at -3 and 2/3. I'm a little bit further away. At 3, I'm at -3. At 4, I'm at -1. And at 5, I'm at a +5. I was able to graph more points. So we can see a little bit different here. And this one is the best graph. Do I need to label any points on this graph? I have a David value, so we're all good. It's stuck. Sorry, man. Easy peasy, right? None of this is really hard. You guys have done transformations till the end of time. So by this time, if I give you your chapter 1 test again, 100% across the board, I'm sure. So again, I'm going to take a moment. I'm going to do my table of values for my y equals to the exponent x. I'm just going to stand here and make an X on the board. So negative 2 and 1/4, negative 1, 1/2, 0 and 1, oops, 1 and 2, 2 and 4. So if I were to graph this, you guys are going to get so good at graphing this stuff. So there's my asymptote for my original one. I'm going to put a dash line on for this one. All right, so we've got some reflections, and we've got stretch as well. So what kind of stretch do we have? Horizontal. Horizontal. And we have a reflection in the y-axis. But really, mathematically speaking, we're only messing around with the x's, right? We're timesing all the x's by what? Negative 1/2. Of course, that's what you meant. Anything happening to the y's? Nothing. So this is going to be nice. I can just put these back in. So for my x's, I'm timing them by a negative 1/2. So that's going to be a positive 1. A positive 1/2. 0 is still going to stay 0. 1 is going to go to a negative 1/2. And 2 is going to go to a negative 4. Did I do that right? Nope. Where were you guys? This should be negative 1. Should it not? I rely on you guys a lot to fix my math. It's making me cry. So 0 and 1. What do we call that point that's shared by the parent graph and then the transformation graph? Invariant point. Just a friendly reminder. So at 1, we're at a quarter. And at 1/2, we're also at a half. At negative 1/2, we're at 2. And at negative 1, we're at 4. Now all of a sudden our curve is going to be a lot steeper. My asymptote is going to stay the exact same because there was no shift. So this one is f of x equals 2 to the exponent negative 2x. Do you have to graph the asymptote? No. Okay, but let me be very clear with this. If you don't put your asymptote on there and you cross the asymptote you didn't draw on, that's going to be a half-mark deduction minimum. So why were you? I put my asymptotes on. That's my favorite. That would be my worldly advice for you guys. If you choose not to listen to it, I can't stop you, but you have to follow the asymptotic behavior. All right, last one. Can you graph the original without a table of values? Pardon? Okay, fair enough. So this is my y equals 3 to the exponent x. So what am I doing mathematically speaking? What am I doing to my y's? Multiplying by 3. What am I doing to my x's? Adding 1. Okay, so here we go. Maybe, David, you're right. Maybe I need to put my table of values. you're right. Oh, see? This is why I need you guys. Very important. So -2, -1, 0, 1, 2. So I'm going to have positive 1/4, 1/2, 1, 2, 4. Woo! I'm going to go to blue again. So the x's, I'm adding 1. So this is going to be -1, 0, 1, 2, and 3. Woo, that was easy. For my y's, I am multiplying them by 3. So 3/4, 3/2, 3, 6, 12. If it's easier for you guys to see it and putting it in decimals, that's fine, but I just going to forewarn you on the exam, you're probably not going to have a calculator for a graph like this. Okay, this is a pretty basic graph. You're going to be okay to do this one on your own without a calculator. So I'm sure you all can convert 3/4 into a decimal, 3/2 into a decimal, but just keep that in mind. With probably something like this you won't get on the actual exam. Hey, where's my asymptote? Where's my asymptote? Where's my asymptote? 0. Did I have any vertical shift? No. That's the only thing that's going to affect that asymptote is the vertical shift. So my asymptote is still going to be at x equals 0. I'm being a wild child just because I'm trying to not hate this technology. And I'm just going to graph that function. So -1 and 3/4, 0 and 1.5. 1, 3, and I'm off the grid. Okie dokie. If you don't have a table of values, you really do need to make sure 2 points are labeled. You also need to, which I didn't do on this one, what else am I missing? If you were to look at this graph, how would you grade me? I labeled my function. That's good. I made a table of values. What am I missing, Blaze? Didn't label my axes. That, I believe, is a half mark deduction. So we need to tighten up our skills in that area. Because that's something I'm bad at